Well, kids, I hope you had a good test. You're actually taking it right now, but by the time you watch this, you will have already finished.
If you watch it.
So, test review. Kiddos are writing down a test review. We're going to go grade section 12.5 and the worksheet. But, worksheet odds. I was warning them in this test review, the one thing that's not there, you guys listening? The one thing that's not there that's on the test tomorrow is the worksheet. So we'll spend a little extra time on that today because the worksheet, there will be a few problems on the test tomorrow using basic derivative rules. Well, I guess you could do it the definition way, but that'd be awful. All right, the two evens from yesterday. Number 4 was a vocab area. And number 8. Number 8 was actually kind of basic. You were using that formula that I think is still on the board. Is it still up there? Yeah, I squared. N times n plus 1 times 2n plus 1 over 6, but n equals 30. Robbie, we good? So then you plug in 30. There you go. One of your big questions for tomorrow should be, can we use our calculator? And the answer is yes.
Oh, yeah.
Ooh, which is interesting because I showed you how to do at least a couple things on your calculator. Okay, so before we go to the test review, do you guys have any questions on homework that you want to talk through? I have section 12.5 open. Vigo. 43 and 23. All right, I'm going to start there because there weren't that many problems in homework, and I bet these are probably the hardest. Because if Vigo's asking, there probably are. Kim, anything else? 25, 23, 25, and 43. You guys ready? I'm going to go ahead and do it over here on the webcam. That way I can kind of bust them out a little bit faster than normal. I want a light colored one. I want this one. I want a light colored one. Okay. Number 23 is first, and he is right here. Okay, we have 8 rectangles that we're supposed to be approximating the area under the curve width. So as I start, ooh, that's too zoomed in. Hold on, let me just write down my function. So f of x, ooh, not a green marker. No. Let's do a black marker. F of x is equal to 1/4 x cubed. I'm going from, did you guys think it was 0 to 2? Is that about what it looks like, right? X equals 0 to x equals 2. Trying to approximate, but I guess I'm actually approximating with how many rectangles? 8? Ooh, there's a lot of rectangles. Maybe I should make this a bit bigger. Okay. If we were splitting 0 to 2 into 8 pieces, yeah? Let me zoom out. Okay, if we're splitting 0 to 2 into 8 pieces, did you guys figure out how wide your rectangles would have to be? Yeah, 1/4. Because you would have to think your bases need to be 2 minus 0 all over 8, which would be 1/4. And this marker's a bit too thick. Can I find a thinner marker? A thinner marker? Aha! Got it. Okay, so I'm going by 1/4, which means, let's see, if I cut this in half, that would be 1, right? If I cut that in half, that'd be 1/2. That'd be 3 halves. If I cut that in half, there's my 1/4, there's my 3/4, there's my 5/4. Yeah, and then this one would be 7/4. Okay, now I have to look at my rectangles. Do you guys see how at 2, this rectangle goes up and hits the curve and juts out? So at 2, I'm going to get a height for that rectangle. At 7/4, Robbie, you focus. I'm going to have a height for that rectangle. At 3 halves, I'm going to have a height for that rectangle. At 5/4, I'm going to have a height for that rectangle. Okay, so 1, 2, 3, 4. At 1, 5, 6, 7, 8. Got him. Well, I got a picture of him. Robbie, stop talking, please. Thank you. Because there is a problem exactly like this on the test as far as the type of problem. Fewer rectangles to save on time, but the exact type, and it's a long answer question, which means you will get lots of points from it, or you will lose lots of points by not doing it. So, what have we done? We've thought about the picture of f of x equals 1/4 x cubed. We have our 8 rectangles depicted, and now it's time to figure out the areas. Now, guys, could I do A1, A2, A3, A4? Could I do that all the way to 8? But wouldn't that be really tedious? So we're going to try and see if we can find any patterns, because if we can find any patterns, and since we're able to use our calculator, maybe we can put some of this together to just go one long string of work in our calculator. But first I'm going to change my y1 to be 1/4 x cubed. First I'm going to change my y1 to be 1/4 x cubed. Now I'm going to put this off to the side, and we're going to think about this. For each rectangle, guys, what's the distance of their bases? Because an area of a rectangle is, what's that formula again? Good, base times height. So I'm trying to find bases and heights to plug into this whole like 8 areas below, but I'm really trying to summarize it in a way that I can just go straight to my calculator. So what are the bases going to be for every single one? 1/4. So you can always do your b minus your a, your 2 minus your 0, and cut it into n rectangles, however many they tell us, which they told us 8. So I can say, wait, if all of these are 1/4, isn't there going to be a common factor of 1/4 for all of them? Oh, okay, so maybe I could, back here in my home screen, maybe right now I could say, well, 1/4 is going to be times a huge long string of, well, other things. So right now I know that my area, or my approximate area, that's technically what we're doing, is going to equal 1/4 times, now, bases, I look down here, little delta x's. Heights, where do I go? F of x's. So do you see how the very last rectangle hits at 2? Okay, what would be the height of this very last rectangle? How do I know it's 8/3 for this very one right here? Good, I plugged 2 into my function. So this very last one would be f of 2, which does end up being 1/4 times 8/3, and that would be my very last rectangle. But what's the problem? How many other rectangles do I have besides the last one? Ugh. Okay, well, is there a pattern? Guys, what would be the x value used to find the height of the first rectangle? I used 2 for this one. I'm using 1/4 for this one. So f of 1/4 would be this guy. Who would be the height of the next guy? F of 1/2. Do you see it? F of 1/2 would be the next guy. The next guy would be f of 3/4. So is there a pattern? And the answer is yes. What's the pattern? Goes up by 1/4 every time, starting at 1/4 and ending at 2. So what I could do, because a calculator is a really nifty thing, do you guys know that you can alpha trace? Do you follow my fingers? You can alpha trace, get a y1 variable, and y1 says, oh, hey, go to this dude, and what do I want to do to that dude? I want to plug in 1/4. I'm going to do decimals because it's way easier to plug in, but I'm not going to stop my parenthesis. I'm going to say plus, because technically, guys, isn't it going to be f of 1/4 plus f of 1/2 plus f of 3/4 plus, aren't I going to go all the way to 2 and then be done? And I'll have base times height plus base times height plus base times height plus base times all the heights. So what am I going to do? You guys finding that y1, alpha y equals? It saves you so much time. Alpha trace.
Oh, you said all. That's why there's going to be less rectangles than 10.
Yeah. I'm not going to make you do 8 on the test. Maybe something like 3 or 4 or 5, but definitely not 8. Where am I at? 0.75 is 3/4. Now I have 1. I have to go all the way to 2. So then what would be the next one, guys? I've done 0.25, 0.5, 0.75, 1. Yeah, 1.25. Good. Plus alpha trace. So do you think you want your calculator on the test tomorrow?
Yeah.
Yes, bring a calculator for the test tomorrow. And then when do I get to stop? When I finally get to 2. This is what in calculus we call a Riemann sum. The approximate area would equal 1.266, and this is all the work that I would need to see. This formula and this answer. Does that make sense? But how on earth did we figure out 1/4 again? Because that ended up being super important, not only for the bases, but also for the heights, what we were counting by. Where'd the 1/4 come from? The the formula which says in order to get the base, I can do b, which in this one was 2, minus a, which in this one is 0, all over however many rectangles. And that came back to the very beginning picture. B was 2, a was 0, and 8 was our rectangles. Does that make sense? Does anybody want a quick picture of that? Has anybody not gotten there yet? If so, you can grab a quick picture of it. That would be a good thing to look at for tomorrow. Now, what if I was to ask you another question, which I don't think the book did. Let me check. 23, 25, and then 43. 43 kind of does. But what if I was to ask you for the exact area? Yeah, we'd be going to infinity, but what if I said something like you were allowed to use your calculator? Do you remember how yesterday? What operation or what function finds the exact area? What calculus operation finds the exact area? Integral, good. What if we're looking at the graph and we're going from 0 to 2?
7.
What about 7, Kyle?
As soon as I want to say factorial, integral.
But 7, if I just hit the number 7, it just randomly types in 7. So what's 7?
Oh, second. You have to find the lower number.
Oh, second trace?
Yes.
Good. Second trace. If you go to this menu with all the cool stuff, if you go number 7, you can go from the lower limit of 0 to the upper limit of 2, and it will find the exact area. What's the exact area? 1. So Tony said something about the limit process, and that's what Vico's question on 43 was. We're going to go look at how to do it by hand. But if there's a bonus question, do you think I'm giving a hint right now?
Yes.
Yes. If there's a bonus question that says find the exact area, and you're allowed to use your calculator, do you see what I just did? You can use that second calc menu to do the integral from 0 to 2 under or of your function. And then you can get the exact answer. And that's what I just showed you with my calculator. There was another way to do it with the math button, and there's something called FNINT, function integrate. And you can actually type in all the cool, nifty looking stuff. You could put in your 1/4 x cubed. You could do it this way too. Either way it works. But I kind of like the graph one, since hopefully you will have already put it in there in doing all your rectangles. And then you can actually see it shade and be like, I know what I'm doing. Yay, the answer is 1. Okay, but that was number 23. Kim, number 25 is going to be kind of similar, except number 25, the directions get a little bit harder. Because then they say, okay, we have this function. We move them up. For this one, it's just a line, which is actually, we can kind of cheat on him just a little bit. Yeah, just a little bit. If we're trying to find the exact area, it'd just be area of a triangle, 1/2 base times height. But they're having us use this rectangle idea again. It says